Guards have a single responsibility, which is to determine whether a given request is allowed access to something. If the request meets certain conditions, such as permissions, roles, ACLs, etc., it will be allowed access to that route. If the conditions are not met, then it will be denied and an error will be thrown. One of the best use cases for guards is authentication and authorization. For example, we could implement a guard that extracts and validates a token and uses the extracted information to determine whether the request can proceed or not. Since there are many different approaches and strategies to handle authentication and authorization, in this video we'll focus on a simplified example and learn how to leverage guards themselves in our projects. If you're interested in learning more about authentication itself, check out our separate course extension, which is particularly focused on the implementation of an enterprise-grade authentication feature and all of the complexities that go along with that. Alright, so to learn how guards work conceptually, let's create a guard that is responsible for two things: validating whether an API key is present within an authorization header, and secondly, whether the route being accessed is specified as public. Let's call this new guard API Key Guard. Let's fire up the terminal and generate a guard class using the nest CLI. Let's enter in nest_guard common/guards/API-key. Note that we generated this guard in the common directory where we can keep things that aren't tied to any specific domain. Alright, so let's open up this newly generated API Key Guard file and see what we have inside. As we can see, the nest CLI generated an example guard for us, without any logic inside, of course. Similar to providers, a guard is just a class with the injectable decorator, which we've seen in previous videos. One important requirement of guards is that they should implement the canActivate interface exported from Nest.js Common. This interface requires us to provide the canActivate method within our class. This canActivate method should return a boolean, indicating whether the current request is allowed to proceed or denied access. This method can also return a response that's either synchronous or asynchronous, such as a promise or observable. Nest will use the return value to control the next action. If it returns true, the request will be processed. If it returns false, Nest will deny the request. Looking at the example code the Nest CLI generated for us here, we have return true hard-coded for now. This means that currently every request will be allowed to proceed. Just for testing purposes, let's change this line to return false, indicating that every request should be denied access. And now that our initial mock guard is all set, let's bind it to our application globally. Let's open up the main.ts file and add app.useGlobalGuards, passing in our new API key guard inside of it. Great. Let's make sure that our application is running in the background, and let's navigate to Insomnia and test any endpoint. As we can see, all of our endpoints now respond with status 403, forbidden resource. Just as we expected, it worked perfectly. But right now, our guard is not programmatically determining anything about our route or the caller yet. It's simply always returning false. That doesn't make much sense, right? Instead, let's set up our guard to handle the scenario we talked about in the beginning of this lesson, which is to validate an API key that should be present within each request, but only on routes that are not specified as public. So how can we get started here? Well, first, let's define this API key that we're talking about. To make sure that we never push this secret key to our Git repo, let's define the API key as an environment variable. Open up our .env file that we created in a previous lesson, and let's add the following API_key line. The API key here is just a random generated string, so feel free to use whatever you'd like for this example. With this in place, let's head back to our guard. Here in our guard, we want to retrieve the API key from any incoming request that is not labeled as public. We'll be handling this public part in a moment. For our API key, let's assume that the caller is passing this key as an authorization header. To get the information about this incoming HTTP request, we'll need to access it all from the execution context, which inherits from arguments host, which we've already familiarized ourselves with when we used it with the exception filter. We can actually use those same helper methods from before, but this time to get the reference of the request object instead of the response. This switch to HTTP method gives us access to the native in-flight request, response, and next objects, which is exactly what we need. Next, we need to call the getRequest method on it, which will return our underlying platform's request wrapper object. Remember, in Nest this is expressed by default, but it could also be swapped for Fastify. For better type safety here, let's specify the type as request, importing this type from the express package again. Now let's use this request object to retrieve the authorization header from each request, if it's even there. Lastly, let's compare the authorization header passed in with the registered API key we have stored in our environment variable. For now, we'll simply access the environment variables using the process.env object, but ideally you'd want to leverage the config service instead. With all of this in place, let's open up Insomnia and test any endpoint in our application and see if our guard works so far. As we can see, our application responded with the status 403 forbidden resource. Since we didn't pass in any authorization header, especially one with our specific API key, it looks like our guard's working perfectly. Let's try this same API request again, but this time, let's add an authorization header with the correct API key. With this in place, let's hit send and call the endpoint again. Perfect. We got a 200 response back and no error this time. Our guard was able to verify that the authorization header matched our secret API key, and we were allowed access to continue the API request. So far, we've finished setting up the API key validation functionality we wanted, but we still aren't checking whether the specific route being accessed is public or not. In the next chapter, we'll look at how metadata and a few other Nest features can help us achieve just that.